So, sorry, just getting everything set up, but problem 67. So we are given following information. So f of -1 equals 2, f of 0 equals 0, and f of 1 equals -2. So this is just straightforward function values, plotting points, nothing special here. And then we're given derivatives. Oops, that's not right. Maybe. There we go. Okay. So both of these ones are 0, and at 0 it does not exist. And then we're given some information about the derivative on the intervals. So it is positive and negative. So positive on -∞ to -1 and 0 to 1. Does everyone know what this notation means?
Isn't that just a union?
Yeah.
Yeah, exactly. It's a union. And then again, we're negative for -1 to 0. And oops, I wrote that down wrong. So this should be 1 to infinity. I have my book slightly lower than the table and it's throwing me off. Okay, and then this should be 0 to 1. Awesome. Okay. So this is the information we're given, and using that, we want to draw a graph. Okay. So our first step whenever we're drawing a graph is to simply just draw our axes. Okay. So just 2 lines, and then we want to label them. So going back to 9.1 and that kind of stuff, how are we going to label these axes? Anyone remember? Too shy to say? Okay, so horizontal is X, and typically we say vertical is Y, but in this class we're going to call it f of X, but it's the same idea. Okay? So we have our axes labeled. Now we want to increment our axes. What do you think we could increment by?
1.
Perfect, 1, yeah. And I'm just gonna label every other one to save some time. Ooh, those are not evenly spaced. Okay, awesome. So this is kind of the building blocks for any type of these problems. Now, since we've moved online, this part of the problem is not as essential because you'll usually be given this information, but I still want to establish the basics of it. So now that we have our graph all drawn up, now we need to actually use this information up here that we're given. Okay, so first and foremost, our points are most important. So we're going to plot our points first. We're going to go over to -1 and up 2, and we're going to plot that point first. And then 0, 0, that's just right here. And then 1, -2. Okay, that's what we always want to do first, is just plot our points. Okay, now what does this information tell us? Anyone have a
It's a
guess?
line.
Not exactly the Y.
I meant line.
Sort of. What about the line?
It
Like if
goes
it does
down
not
to
exist, we'll make a corner. And then if it's 0, it'll be like horizontal, or I can't remember the other one.
No, perfect, exactly. So this tells us kind of what the line will look like, while either horizontal, negative, positive, vertical, corner, that kind of stuff. So what we're talking about here is this tells us our slope, right? The derivative tells us our slope. So the way that I am going to mark that is using dashed lines, okay? So whenever we have a slope of 0, I'm just gonna put a dashed horizontal line there, okay? And then when we have a slope that does not exist, a derivative that does not exist, there's two possibilities there. Either we have a vertical slope or a corner, okay? But to denote that, I'm just gonna put a dashed vertical line there, okay? So now we have used these two pieces of information. Our last one are for these guys. Okay, so let's do this. Let's keep this in black. What does this tell us?
If
The
it says
derivative being
positive.
positive. What does that tell us? What does a positive slope look like for a line?
It's going up.
Yeah, exactly. It's something kind of like that. So actually I did change my mind. So when we have a positive slope from negative infinity to -1, we're increasing there, okay? And then 1 to infinity, we are increasing again. Okay, so I like drawing these little dashes and these little arrows to kind of give myself a rough outline of a sketch. Now, what about for this one, slope being negative? What does that look like?
It's going down.
Yeah, exactly. We're decreasing there. So -1 to 0. So right here, we're gonna be decreasing. And right here, we're gonna be decreasing. Okay, so now you can already tell following these arrows and the dashed lines, we can get a pretty good idea of what our graph looks like just from that little bit of information. So all we have left to do now is just to connect the dots, really. So I'm gonna start down here, that doesn't really matter, and then I'm gonna really over exaggerate making that part horizontal, okay, just to really make sure that I know what I'm talking about. And then here, we want to go slightly vertical if we can, because we know that the slope doesn't exist there. So we're going to go slightly vertical, and then we're decreasing again, horizontal, and then back to increasing. Okay, so the line is a little messy, but you kind of get the idea of what we're going for here. And if we were doing this on paper, the main thing I would tell you is really over exaggerate those parts of the derivative that you know. So here, you know it's vertical, so try to really over exaggerate that. Here it's horizontal, so really over exaggerate that bit. But once you kind of have the little arrows and the dashed lines, everything kind of falls together. But do you guys have any questions on how to set this problem up? No questions? Okay, cool. Are there any other problems you guys want to go over? What about one of the ones from like 11.1b, where you're not drawing a graph, but you're getting intervals and critical points and local extrema. All that makes sense?
Sounds good to me.
Yeah, so far so good for me.
Okay. Well, do you guys want to go over a problem where you have to do everything by hand, basically finding all of this information by hand?
Yes.
Yeah, okay. So I will pick a problem then. So let's look at, let's look at 47, because you have some nice derivative techniques to work with there as well. So this was 11.1a, and then we're going to move down here for 11.1b. Okay, looking at 47. So the function that we are given there is x squared minus 4 to the 2/3. And we are asked to find intervals where it's increasing, intervals where it's decreasing, and local extrema. Okay. So we kind of hinted at it up here with this problem, but how do we know when the function is increasing and decreasing? Do we guess? Do we plug in numbers and see when the numbers are going up and when they're going down? What do we do?
Yeah, I do that second part. I just kind of make a rough draft, kind of just plot out the general idea, and then just make a final draft after I see what the graph looks like.
Well, for this one, you actually don't need to do any graphing, actually. There's a pretty quick and nice way to tell if something is increasing or decreasing. Okay, so let's go back up to this graph. Let's look at this problem again. Where on this graph are we increasing and where are we decreasing?
We're increasing from negative infinity to 1, and then from 1 to 2, we're decreasing, and then from 2 to infinity, we're increasing.
Really close. Right here, we're at -1, and here we're at 1. But yeah.
Oh, right.
Yeah. So is there any correlation with this information? To what you just said?
I'm not really sure. I usually just kind of plug in numbers and go from there.
Okay. So what you just said is we are increasing from negative infinity to -1. Well, look at right here. From negative infinity to -1, our derivative is positive. And then again, from 1 to infinity, we're increasing again. Well, that's the same thing here. So in these intervals, we're increasing. Oops. Okay. But that's where the derivative is positive. Okay. And then similarly, here we're decreasing from -1 to 0, and then 0 to 1. Okay. And then that is when the derivative is negative. So to find intervals where the function is increasing and decreasing, we look entirely to the derivative. We can just find the derivative and go from there. We don't really actually need to work with the function at all. Okay? So let's start there. We know we need to find the derivative. Okay? How can we find this derivative? What do we need to use?
Is it the chain rule? No, the
Perfect.
power. Oh, okay.
You are completely correct. Chain rule. Yep. Okay, so let's break out old school chain rule, do outside, inside, just to refresh ourselves. What's going to be the inside function here?
X squared minus 4.
Perfect. And what is that derivative?
2x.
Awesome. And what does that mean that the outside function has to be? Sorry.
It's I to the 2/3,
Mm-hmm.
and then it's 2/3 I to the negative 1/3.
Awesome. Okay, so then what is this derivative going to look like?
2/3 2/3, and then parentheses x squared minus 4
Mm-hmm.
to the negative 1/3 times 2x.
Awesome. Awesome. Okay, and then we can just simplify that guy a little bit and do 4x over 3 times x squared minus 4 to the negative 1/3. And actually down here, I'm going to rewrite that again. Okay, and this step is optional. It will just make our life a little bit easier down the road. Okay, so we now have our derivative. And we're going to look back up here again. To find where the function is increasing and where it's decreasing, we want to find where the derivative is positive and negative. But what do we know? Where can the derivative change sign from positive to negative? Think about just like a regular function, okay? So here, you're going from negative to positive. What did you cross to go from negative to positive?
The x-axis.
X-axis. And what is the value at the x-axis?
2 or no?
What is the value of y at the x-axis?
Oh, it is 2.
It's 0, right?
0, exactly. So one of the ways for a function to change sign, it has to go through 0. Okay. The other possibility is well, we could have where it's just the derivative isn't defined somewhere. So it doesn't cross an axis at all, but it's just not defined. Okay, so that's 2 ways that we can find values where the derivative can change signs. Those values where the derivative can change signs, those are called critical points. Does that sound familiar to anyone? Yes, no, maybe?
Yeah, kinda. I think there's a different word for it that I don't know what it is, but
0 or it's undefined, right?
yeah.
Those are the critical points.
Exactly. Critical points, values where the derivative is 0 or undefined. So to find intervals where the function is increasing and decreasing, we need to find our critical points first. Okay? So what do you guys want to look at first? Where it's 0 or where it's undefined?
Let's just start with 0.
0? Okay. So we have 4x over 3 cube root x squared minus 4 equals 0. Okay, but what do we know about functions that have a numerator and denominator when we set them equal to 0? What can we do?
Would we multiply each side by the denominator?
Exactly, and what does that leave us with when we do that? If we're getting rid of this denominator, what is left?
The denominator?
Well, we're
Well,
getting
numerator.
numerator, exactly. And when we multiply 0 times anything, it's still 0. So anytime we have a function with a numerator and denominator, and we're setting that whole guy equal to 0, we can just skip a step and just set the numerator equal to 0. And it's the exact same thing. Okay, now where is 4x equals 0? For what values of x is that true?
Just 0.
Exactly, x equals 0. So we know that the function equals 0 when x equals 0. Awesome. Now what about where the function is undefined? How can we do that? Where can it be undefined?
Isn't this when the numerator is equal to 0? Or is the denominator equal to 0?
What do you want to do instead?
I think it was the numerator that was 0.
Well, we did that up here. When we're looking for where the derivative is equal to 0, we set the numerator equal to 0.
Oh, right. So it's the other way around.
Exactly. So when we're looking for where the function is, the derivative is undefined, we can just set the denominator equal to 0. Because we know that we can never divide by 0. So anytime we are, that's where it's undefined. Okay. How can I get rid of this guy?
Divide each side by 3.
Exactly. And then how would I get rid of this guy?
Take the cube root, or
No, you're
what do you call that? It's not square rooting. No, it's not squaring it. It's
cubing it.
Cubing it. There we go.
Exactly. But still, we'll have 0 over here. So we can just drop that 3 and that cube root and just look at whatever is underneath and set that equal to 0. So we know in the back of our mind why we can do that, but we can actually just skip all that stuff the same way we could up here. So then we get x squared equals 4. X equals, how many answers should I have here?
2.
2. So we're going to have plus or minus 2. So now these numbers here are our critical points. Okay. Now that we have critical points, we can construct a sign chart. So a sign chart is for the derivative, and it helps us see when the derivative is positive and when it's negative. Okay, so these are our values of x, and this is going to be f prime of x up here. We know at 0, the derivative is 0, and at 2 and negative 2, it's undefined. Okay. Now we want to find out in this interval and this interval and this interval and this interval whether the derivative is positive or negative, because that will tell us if if the function is increasing or decreasing. Okay, so what we can do here now kind of goes back to the original idea that you guys had. We can just pick numbers. So in this first interval here, we want to pick a number between negative infinity and negative 2. I say go easier if you can. Okay, so let's look at this derivative we have up here. Okay, so when we plug in a number that's less than -2 up here, is this numerator going to be positive or negative? Say we plug in -3. What are we going to have up there? Positive or negative?
Negative.
Negative, exactly. So we're going to have negative in the numerator, and then what about in the denominator? Say -3. Well, any number squared is still positive. So we're going to have positive number minus 4. But say we had -3 in there. This would be 9 minus 4. That's a positive number, right?
Yeah.
Take the cube root of a positive number, still a positive number. Multiply it by a positive number, still a positive number. So here we have a negative divided by a positive. What's negative divided by positive?
Negative.
Negative. So for this interval, we are, let me write that differently. We are negative here, okay? And I'm gonna write this derivative again off to the side. Okay. Now, what about in this interval? Say we took -1, okay? When we plug in -1 up here, positive or negative?
It's gonna be negative.
Negative. What about any number squared is positive still? So 1 minus 4, positive or negative?
It's still a negative.
Still a negative. When we take a cube root of a negative number, it's still negative. So this is now negative divided by negative. So what's that going to be?
Positive.
Positive. So we can already see we are decreasing in this interval and increasing in this interval. Okay, awesome. So now let's move on to 0 to 2. Okay. When we plug in a number between 0 and 2 up here, say 1, is that going to be positive or negative?
Positive.
Positive. Okay. And since we're squaring the number, we're going to get the same sign in the denominator. So we're still going to be dividing by a negative. So what happens when we have a positive divided by a negative?
We're gonna have a negative.
Negative. Okay. And then our last interval, 2 to infinity. We already kind of have an idea of what it should be from these other ones, right?
Yeah, it's gonna be positive.
It's going to be positive in the numerator, and it's still going to be positive in the denominator. So, like you said, we're going to have positive there. Okay? And remember that when we are negative, that's decreasing. Positive is increasing. Negative is decreasing. Positive is increasing. Okay? So we are increasing on what intervals?
-2 to 0 and 2 to infinity.
Awesome. And we are decreasing on what intervals?
Negative infinity to -2 and 0 to 2.
Awesome. Okay. Now the other part of this question, oh wait, I wanted that there, is our local extrema. Okay, so local extrema, that's talking about local min or local max. And that's partially why I drew these little lines underneath our sign chart, because look here, when we switch from decreasing to increasing, what is that going to be? A minimum or a maximum there?
That's gonna be a min.
A minimum. And what about when we switch from positive to negative, increasing to decreasing? What are we going to have there?
A maximum.
Maximum. So we have local minimum of f of -2 and f of 2. Because whenever you're asking for a local extrema, you're asking for the function values. If you're asking for where local extrema occurs, you give the x values. And then local maximum, that's going to be our f of 0. Okay. Are there any questions on this problem? I didn't get a chance to look at the quiz online at all, so I'm not entirely sure what exactly is on it, but I know it's going to be identical to my math lab and your homework, your notebook problems. But is there any questions that you guys have for me on any of the other content?
I'm good on my end.
Okay.
Yeah, I'm good too.
Awesome. Well, if you guys do think of any more questions, you are more than welcome to email me. Remember that you do only have 15 minutes for the quiz, so ask your questions before you go in. But yeah, so if you think of anything else down the road, you're more than welcome to ask me anything. But otherwise, I think we are good to end discussion if there aren't any more questions. Okay, cool. So hopefully you guys all have a good rest of your day and good luck on the quiz. Let me know how it goes, and then I will see you guys on Thursday, and I will try to get these notes and this recording posted by 5.
All right, you have a good one.
Yes, you too.